As is known to all, since the beginning of the Russia-Ukraine war, Russia has already exposed its shortcomings and disadvantages in drone technology. The drones widely used by the Russian army on the battlefield currently include small reconnaissance drones such as Orlan-10, El-Iran, and Forpost, as well as suicide attack drones loitering munitions of the Lancet series. The large number of the remaining drones used against individual soldiers are all modified products of commercial drones. The existing drones in Russia present a basic characteristic. That is, the product line is incomplete and a large number of chips have to be purchased. Besides lacking specialized military individual-use drones, the Russian army has a particularly large gap in the field of reconnaissance strike integrated drones, even for the existing finished drones. A large number of foreign-produced chips are also required. These problems have had a relatively large negative impact on the frontline operations of the Russian army. For example, civilian small drones like DJI can indeed become bomb couriers after being modified, but their basic structure is still not designed to adapt to the battlefield environment. On the vast Ukrainian plain, the signal of DJI is relatively good. However, in mountainous and hilly areas or in the urban areas with high-rise buildings in Ukraine, the signals of these civilian drones are easily interfered by various objects in the natural environment and become uncontrollable. This is the case with the natural environment, not to mention in high-end battlefields with complex electromagnetic environments. Commercial drones are definitely difficult to adapt to such combat requirements. Nowadays, both Russia and Ukraine are extremely lacking in anti-drone equipment, which is also a fundamental reason for the proliferation of small commercial drones on the Russia-Ukraine battlefield. However, this does not mean that commercial drones have the same anti-interference ability as military drones. The Russian army must be clear about this. Therefore, the DIY drone experience on the Ukrainian battlefield may not be able to stand up to scrutiny in the future. The fact that the Russian army lacks reconnaissance strike drones has also put the Russian army in a passive position in many combat operations. For example, in the Bakhmut battlefield where Russia and Ukraine had fierce confrontations in 2023, the two sides have been locked in a deadly struggle here for at least a year. The total casualties of both sides are said to have reached tens of thousands. Before the war, Bakhmut was just a small town with a population of only 50,000, 70,000, and an area of only about 41 square kilometers. Throughout this campaign, the Russian army did not have any drones similar to the Wing-Lung 3 participating in the battle. Just imagine, if the Wing-Lung 3 had participated, the Russian army would definitely not have to fight so hard and suffer such heavy casualties. After all, the Wing-Lung 3 drone is the pinnacle of domestic reconnaissance strike integrated drones, and the Wing-Lung has been exported to 11 countries so far. It is characterized by long range and large bomb carrying capacity. According to the data, the high speed of the Wing-Lung 3 is 370 kilometers per hour. It can conduct continuous combat in the air for nearly 40 hours. The maximum range can reach 10,000 kilometers, and the combat radius is approximately 4,600 kilometers. Its maximum takeoff weight is 6 tons, and the total bomb carrying capacity exceeds 2.3 tons, with a total of 8 attachment points. Take the Fab 1500 thermobaric bomb most commonly used by the Russian army. As an example, it has been reported that this kind of bomb once killed hundreds of Ukrainian soldiers at one time. If the Russian army had the Wing-Lung 3, there would be no need to dispatch the Su-34 to carry the Fab 1500. The drone could be used directly. The number of sorties of drones can far exceed that of manned aircraft. The use and maintenance costs of drones are very low, especially compared with the Su-34. In this way, the precious Su-34 aircraft can be used to perform other tasks. More importantly, It would not be a great pity even if the Wing Lung 3 is shot down. The Russian army doesn't have good quality drones. Speaking of which, the Lancet is fairly good, but it can't perform multiple tasks. It is just a suicide drone. It can be seen that in the entire drone field, Russia still lacks a lot. Actually, the development of drones in the Soviet Union and Russia started not too late. But it is really a pity that it has come to this situation today. In fact, as early as the 1930s, the Soviet Union had already started to develop drones. The first drone manufactured by the Soviet Union was a radio telemetry drone modified from the Yak-9B fighter, which was mainly used to monitor nuclear radiation. In 1960, the TUP-OLV Design Bureau successfully developed the Tu-130 strategic reconnaissance drone and equipped it in Soviet troops in 1965, with a cumulative production of more than 50 aircraft. The TUP-OLV Design Bureau continued to make efforts in the following 20 years and developed the Tu-143 and Tu-243. The Yakovlev Design Bureau also did not lag behind. Small-sized tactical reconnaissance drones such as the B, Albatross and Dragonfly are all representative works of this design bureau. Before the 1990s, the Soviet Union had already formed 25 drone brigades, and the total number of drones was nearly 1,000. However, after the 1990s, while the military expenditure of the Russian army was drastically reduced, many high-ranking officials within the army were not optimistic about the development prospects of drones and directly disbanded 17 of the 25 drone brigades. The management authority of the remaining drone brigades was also handed over to the army. Since then, almost all Russian drone research and production institutions have been shut down, and a large number of technicians have gone overseas to seek a living. Later facts proved that without good reconnaissance drones, the Russian army performed very poorly in the two Chechen wars. It was not until after the Russia-Georgia War in 2008 that Russia began to attach importance to the development of drones at the official level. A large number of documents and policies were issued to support it. And finally some loopholes in the field of drones were filled before the Russia-Ukraine war. It even came up with drones like the Orion that seemed quite good. Before the war broke out, the Russian army claimed to have established 40 drone units and possessed more than 2,000 drones. However, on the Ukrainian battlefield, the performance of these drone units could hardly be described as good, and the Orion didn't even make an appearance at all. Facts have already shown that Russia doesn't have particularly top-notch military drone products, and lacks a lot in terms of technology. With Russia's existing drone technology level, it can neither meet the needs of the Russian army on the battlefield nor is it likely to achieve the future drone aviation development strategy proposed by Russia. And now the one that can offer help to Russia in this field is naturally China. However, it seems that China and Russia have not carried out cooperation at the military level. And the reasons are quite obvious. China needs to avoid incurring the opposition of European and American countries due to such cooperation. So this kind of technological cooperation can only be hidden in the cooperation between the private sectors. Compared with the past, this kind of cooperation has happened many times in the present and will continue to happen in the future, of course. China's technology is not given for free. Russia must exchange something for it. It is clearly stipulated in this agreement that Russia will provide China with the technology of heavy-load helicopters, and even send expert teams to teach Chinese technicians hand-in-hand and apply for patents. And among such heavy-load helicopters, the one that China is most likely to want is the Mi-26. The Mi-26 heavy transport helicopter was born in the Soviet era. For a long time, it has firmly occupied the top position among Soviet and Russian heavy transport helicopters, and is truly a heavyweight transporter. The Mi-26 was developed in 1971 and finally put into production in 1983 after 12 years. Its maximum takeoff weight is 56 tons, and the total load capacity reaches 20 tons. The available transportation methods include internal loading and external sling loading. Its rotor blades are 32 meters long, with a total of 8 blades. The number of rotor blades is the largest among single-rotor helicopters in the world. Besides being used in the military, the Mi-26 is very good at carrying out disaster relief tasks. After the Chernobyl nuclear accident, the Mi-26S, which had undergone anti-radiation modifications, went to the central area of the accident many times to carry out the task of spraying liquids. During the 2008 Wenchuan earthquake, Mi-26 helicopters were also among the rescue helicopters China dispatched to the disaster-stricken area of Wenchuan. It once set a record of evacuating 230 people from the disaster area in just 2 sorties. The Mi-26 not only rescued people, but also transported a large number of bulldozers and excavators to the disaster area, making very important contributions to earthquake relief. China has a total of 4 Mi-26 helicopters, with 2 belonging to Qingdao Helicopter Company and 2 to Harbin Fielong Aviation Industry. However, China has not purchased any more since then. This may be due to reasons such as Russia's unwillingness to sell, the high price of the Mi-26, or China's temporary lack of need. Moreover, China has never carried out reverse engineering imitation, perhaps because of problems with the engine that cannot be solved or other reasons. In recent years, China has achieved considerable development in the field of domestic transport helicopters. However, due to historical and practical reasons, the large-scale transport helicopters that China has successfully developed and equipped in large numbers currently have limited capabilities, and there is still a considerable gap compared with the heavy transport helicopters of the United States and Russia. But for a country like China, heavy transport helicopters are equipment that we must have and whose performance must be advanced. And this cannot be emphasized enough. In fact, as early as 2015, China and Russia reached an agreement to jointly develop a new type of heavy transport helicopter. A model of this helicopter was even exhibited at a subsequent Zhuhai air show. But needless to say, the progress of this project has been very slow. Since 2022, there has basically been no news. The most crucial point is that the medium-sized helicopter jointly developed by China and Russia is actually inferior to the Mi-26. The official information reveals that its takeoff weight is around 38 tons, basically reaching the level of the Sea Stallion. But the problem is that it still only exists in the PPT and has not become a reality. For China, the joint development of heavy transport helicopters by China and Russia doesn't seem reliable. The best solution is still for China to conduct independent research and development. If, as the outside world said, Russia is willing to transfer the relevant technology of the Mi-26, it will be quite useful for China's development of its own heavy transport helicopter.